There's a spacecraft that left Earth so violently, it passed the moon before dinner. The astronauts of Apollo needed 3 days for that same stretch. This thing did it in hours. It was the fastest machine humanity had ever launched. Its destination, Pluto, and even at that speed, the trip took nearly a decade. Here's the strange part. The reason has almost nothing to do with distance. By the end of this video, you'll know how long it really takes to reach every planet in the solar system, and why the true enemy of space travel is something nobody warns you about. Start with the intuition everyone shares. The moon is 3 days away, so Mars, the next world over, should be, what, a week? 2? Here's the problem. At its closest, Mars is 146 times farther than the moon, and Mars is the friendly one. The outer planets are measured in years, sometimes decades. But raw distance is only half the trap. Planets are moving targets on elliptical racetracks. Point a rocket at where Mars is, and by the time you arrive, Mars is gone. Every mission flies like a quarterback throws, not at the receiver, but at where the receiver will be. That long, curved path is the cheapest route physics allows. And when it's still not enough, you steal speed from a planet itself. Swing in close, borrow a fraction of its orbital energy, and leave faster than you came, without burning a drop of fuel. Ellipses, timing, borrowed gravity. Those are the rules. Now watch what they do to the map. Mercury first, the planet next door to the Sun, and one of the hardest places to reach the entire solar system. Flying toward the Sun means flying downhill. Your spacecraft accelerates the whole way, and arriving is worthless if you're moving too fast to stay. NASA's Messenger probe needed 6.5 years and half a dozen planetary flybys just to arrive slowly enough to enter orbit. And this isn't ancient history. Right now, a European-Japanese probe called Bepi Colombo has been falling toward Mercury for 8 years. It finally arrives on November 21st, 2026, 4 months from now. 8 years for the innermost planet. The solar system does not grade on proximity. Between Mercury and Mars sits a warning. Venus is our closest neighbor. Probes have reached it in under 4 months, some of the fastest trips in the solar system. Getting there is easy. Staying is not. The Soviet Venera landers, the only machines ever to send pictures from the Venusian surface, were built like submarines, and the toughest of them survived 127 minutes before the heat, the crushing pressure, and the acid air destroyed it. That record still stands, half a century later. Sometimes the travel time is the least of your problems. Mars, then, the easy one. 7 to 9 months one way with today's rockets. But here's what the brochures skip. You can't just turn around and come home. The planets have to line up again, and that takes 14 to 18 months of waiting on the surface. Door to door, a crewed Mars mission is a 3-year commitment, absorbing a radiation dose that flirts with an astronaut's entire career limit. Nuclear rockets could cut the transit in half. But America's flagship nuclear rocket program was quietly canceled last year. Cheap, heavy rockets changed the economics before the engine ever flew. For now, Mars stays a 3-year trip. Jupiter is where the scale turns cruel. A flyby is quick. Voyager one-shot past in 18 months. But stopping? Galileo needed 6 years. And Europa, the moon hiding more liquid water than all of Earth's oceans combined, our single best address for alien life, sits inside a radiation field that would kill an unshielded human in about 10 minutes. NASA's Europa Clipper, launched in 2024. It arrives in 2030. Saturn is crueler still. Cassini spent 7 years just getting there, then repaid us with 13 years of discoveries so rich that scientists are still mining the data today. And beyond Saturn, 2 entire planets, Uranus and Neptune, have been visited exactly once. Same probe, same decade. Voyager 2 only managed it because the outer planets happened to line up in a pattern that repeats once every 176 years. And NASA launched in 1977, specifically to catch it. The next Uranus mission, on the books. Launch in the early 2030s. First data in the mid-2040s. A scientist who proposes that mission at 40 will be pushing 60 when the pictures arrive. These aren't projects. They're careers. And Pluto? New Horizons. The fastest launch in history, remember? Arrived after 9.5 years and found nitrogen glaciers and ice mountains 3.5 kilometers tall and could not stay. It blew through the entire Pluto system in a single day. And every move it made that day had been programmed hours in advance. At Pluto's distance, even a radio signal traveling at the speed of light needs more than 4 hours to arrive. One way, breaking into orbit would have required 4 times the spacecraft's entire weight and fuel. Quick pause. If your mental map of the solar system just got 10 times bigger, that's exactly what this channel does. Subscribing costs 1 second. And stay with me because everything you just heard leads to a twist. This whole time, you've probably been thinking the problem is that space is too big, or that our rockets are too slow. Wrong on both counts. New Horizons crossed the entire solar system in 9.5 years. We are perfectly capable of going fast. The real tyrant is something else. In space, you cannot stop. No air to drag you. No road to grip. Braking costs exactly as much fuel as accelerating, and every kilogram of brake fuel has to be lifted off Earth and hauled across billions of kilometers just to be burned against your own momentum. That's why the fast missions are all flybys, and the missions that stay take 6, 7, 10 years. The question was never, how long does it take to get there? It's, how long does it take to arrive gently enough to stay? Which leaves one spacecraft with the best deal in the solar system, the one that never intended to stop. Voyager 1 left Earth in 1977 and simply kept going. It is now more than 24 billion kilometers away, the farthest human-made object in existence, still whispering home on about 20 watts. But its plutonium heart loses 4 watts every year. This April, NASA switched off another of its instruments just to keep it alive. Sometime in the 2030s, the last instrument goes dark, and the only voice humanity has ever had in interstellar space falls silent mid-journey. The probe won't stop, though. It can't. No brakes, remember? Long after its signal dies, long after all of us, Voyager will still be out there, falling through the dark. The one trip we ever launched with no arrival and no ending.